Welcome to the session on integration, partial fractions. The objectives for this session are to integrate functions by using partial fractions. A single fraction with two distinct linear factors in the denominator can be split into two fractions. This process is called splitting into partial fractions. So, for example, 3 over x plus 7 times x minus 5 is identical to a over x plus 7 plus b over x minus 5, where a and b are constants. So notice that we have rewritten the expression on the left as the sum of partial fractions. There are two methods of finding constants a and b, either substitution or equating coefficients. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. We are required to split the expression shown on your screen into partial fractions by substitution. So let's solve this. We let the expression equal or be identical to a over x plus 3 plus b over x minus 2. We then add the fractions on the right-hand side by putting them over a common denominator as shown. Therefore, we now have that the numerator on the left-hand side is identical to the numerator on the right-hand side. If we let x equal 2, and we do this in order to get rid of the a term, we obtain 5 times 3 on the left-hand side, and a times 0, this was what we were trying to do, get rid of the a. So a times 0 plus b times 5 on the right-hand side. This gives us b equals 3. Now if we let x equal minus 3, we have 5 times minus 2 on the left-hand side, and a times minus 5 on the right, plus b times 0. And of course, this is why we put x equal to minus 3, so that we could get rid of the b and find a. And so tidying up gives us that a equals 2. So we've found the values of a and b. And we can express our fraction as 2 over x plus 3 plus 3 over x minus 2. Before moving on to part B, let's take a look at some theory. Recall that if you can write a function in the form f dash of x over f of x, then the integral of f dash of x over f of x with respect to x is log mod f of x plus c. Let's now explore part B. We are required to use part A to find the integral of 5 times x plus 1 all over x plus 3 times x minus 2. So let's solve this. From part A, we have that the integral can be expressed as the integral of 2 over x plus 3 plus 3 over x minus 2 dx. And this can be split as shown. Applying the rule on the left-hand side of your screen, we can see that the integral of 1 over x plus 3 equals ln of mod x plus 3. And similarly, the integral of 1 over x minus 2 dx is equal to ln of mod x minus 2. This can be expressed as shown. And then written as ln of mod x plus 3 all squared times x minus 2 all cubed plus c. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's take a look at part A first. We are required to find the constants a, b and c in the identity shown. Before doing that, you may want to remind yourself of the theory. Pause the video and take a look. Press play when you're ready to view the solution. So let's solve this. We begin by multiplying the above identity throughout by 4x plus 1 times 4x minus 1 to give this expression here. Now let's use substitution. We are going to let x equal 1 over 4 to find one of the constants. You may be wondering why we've chosen x equals 1 over 4. And this is so that the constant a then disappears and the constant b then disappears, and we can simply find the constant c. And so if we plug in x equals 1 over 4 into our identity, we obtain that 6 is equal to c times 2. Which gives us that c equals 3. Now let x equal minus 1 over 4. And again, this is so that we can allow two of the constants to disappear. And so plugging in x equals minus 1 over 4 gives us 6 equals b times minus 2. And therefore b equals minus 3. Now since we already have the constants b and c, we can simply let x equal 0 to find the value of a. So plugging in x equals 0 gives us 4 on the left-hand side and this expression on the right-hand side. We've plugged in c equals 3 here and b equals minus 3 here. To give us a equals 2. Now that we have our constants, we can plug them into our identity. So we have that the left-hand side is identical to 2 minus 3 over 4x plus 1 plus 3 over 4x minus 1. Now we can use part A to help us solve part B. Using part A, we're required to find the exact value of the integral from 1 to 3 of 32x squared plus 4 all over 4x plus 1 times 4x minus 1. So let's solve this. From part A, we can express our fraction as shown. And this can be expressed as shown here. integral of 2 dx between the limits 1 and 3 minus 3 over 4 times the integral 1 over x plus 1 over 4 plus 3 over 4 times the integral 1 over x minus 1 over 4. To give us 2 times x between the limits 1 and 3 minus 3 over 4 times ln of x plus 1 over 4 between the limits 1 and 3 plus 3 over 4 times ln of x minus 1 over 4 between the limits 3 and 1 to give us this expression. And tidying up, and finally rearranging gives us this. We're going to carry over this expression onto the next slide so that we have some more space, as shown. This expression can now be simplified as shown here. And finally simplified further to give 4 plus 3 over 4 ln of 55 over 39. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Before moving on, let's take a look at some theory first. A single fraction which has a repeated linear factor in the denominator can be split into 2 or more separate fractions. So for example, we have this equation here, or this identity. The denominator on the left-hand side contains 3 linear factors, namely x plus 7, x plus 5 and x plus 5. Here, of course, x plus 5 is repeated. On the right-hand side, we have a, b and c, which are constants which can be found. The expression on the left has been rewritten as the sum of 3 partial fractions. Notice that x plus 7, x plus 5 and x plus 5 all squared are the denominators. Let's now take a look at an example. We are required to split the fraction shown into partial fractions. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We're going to begin by letting this fraction be identical to a over x plus 3 plus b over x plus 4 plus c over x plus 4 all squared. For some constants a, b and c. Adding these 3 partial fractions together and putting them over one common denominator gives us this expression here. Now, since the denominators are the same, as you can see highlighted in red, we can conclude that the numerators are the same. When x equals minus 4, this is going to allow us to calculate the value of c, because the a term and the b term will disappear. On the left-hand side, we have 2 times 16 plus 19 times minus 4 plus 42 when we plug in x equals minus 4. This is equal to minus 2. And on the right hand side, when we plug in x equals -4, as intended, the a term and the b term will disappear because we're going to multiply each of them by 0. This is what we intended to do, and we're now simply left with c times -1. Therefore, the right-hand side is equal to -c. Since the left-hand side and the right-hand side are equal, we have that c equals 2. When x equals -3, on the left-hand side, we have 2 times 9 plus 19 times -3 plus 42. And this is equal to 3. And when we plug in x equals -3 on the right-hand side, we manage to get rid of the b term and the c term, and this is what we intended to do so that we can find the value of a. So on the right-hand side, we are left with a. Since the left-hand side and the right-hand side are equal, we have that a is equal to 3. So now we have the value of a and the value of c. We only now need to find the value of b. Let's plug in x equal to 0 to simplify our calculations on the left and right-hand side, and also of course plug in a and c in order to find the value of b. So plugging all these in, we have the left-hand side. Of course, the left-hand side doesn't have a, b or c, but we can plug in, of course, x equal to 0. So when we plug in x equals 0, we obtain 2 times 0 plus 19 times 0 plus 42. Giving us that the left-hand side equals 42. When x equals 0, then on the right-hand side, we can plug in a equals 3, c equals 2, and x equals 0 to give us 3 times 16 plus b times 3 times 4 plus 2 times 3. Which once tidied up is equal to 12b plus 54. And so, since the left-hand side and the right-hand side are equal, we have that 12b plus 54 equals 42, giving us that b is equal to -1. We can now plug in the values of a, b and c into our original identity. So c equals 2 goes here as shown, a equals 3 goes here as shown, and b equals -1 here. We now have our original fraction expressed as partial fractions. We are now going to use part A to help us solve part B. as shown on your screen. So let's solve this. Our integral can be expressed as shown from part A. This integral can be written as 3 ln x plus 3 between the limits 2 and 4 minus ln x plus 4 between the limits 2 and 4 plus the integral of 2 over x plus 4 squared between the limits 2 and 4. And so plugging in the limits gives us 3 ln 7 minus ln 5 minus ln 8 minus ln 6 plus this integral at the end. Here we've used the substitution u equals x plus 4. And so the limits become 8 and 6. We also have that du dx equals 1, so dx can be replaced by du. And so tidying up, we have ln 7 cubed minus ln 5 cubed minus ln 8 plus ln 6 plus 2 times minus u to the power minus 1 between the limits 6 and 8 to give us this expression. And finally this tidies up to give us ln 1029 over 500 plus 1 over 12. This brings us to the end of this session. If you have understood its contents, you should be able to integrate functions by using partial fractions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.